Today we will take a closer look at the train wheels, its shape, and the reason behind this shape. First of all, train wheels take a conical shape and not a cylindrical shape. This shape will have two main advantages. The first one is to make the wheels stable on the track, while the second one is to achieve the differential action. Let's explain each of these. When the train wheels are centered on the track, the forces acting on the wheels are shown here, where the reaction forces are perpendicular to the surface of the wheel. The vertical component is going to cancel out with the gravitational force, while the horizontal components are equal and opposite in directions. This is due to the symmetry of the geometry of the wheel, so they are going to cancel each other. Now let's assume due to some reason the wheel has moved to the right slightly. The whole wheel will tilt and the reaction force will not be symmetrical anymore. Instead, the right wheel reaction will have a larger horizontal component than the left wheel reaction. This is going to create a self-centering force that is going to keep the wheels on the track. This is known as a stable configuration, and it is widely represented by this symbol. This is because if you move the ball slightly, it will return to the same position again. Now imagine we have constructed the wheel in the conical configuration shown here. When the wheels are centered on the track, the forces cancel each other, and no problems happened. Now let's give this wheel a push to the right. Can you see the net force acts on the wheels? The net force acts on the wheel is in the right direction. This means it is going to push the wheel even further. That will lead the wheel to leave the track. This configuration is called unstable, and it is represented by this symbol. Notice that this ball will stay in place if no force acts on it, but when a small force or disturbance acts on it, it will never return to its original position. This is why it is called unstable. The extra pieces shown here are for safety. Now let's take a look at the second advantage of the conical shape of the wheel. This advantage is to achieve the differential action. First of all, what is a differential action? When the wheels turns to a given direction, one wheel is going to travel along a part of a circle with a given radius, while the other wheel will travel along a part of a circle with a bigger radius. This means one wheel will travel a greater distance than the other. This means one wheel is going to rotate at a speed larger than the other. This differential action can be achieved in cars by separating the wheels from each other. This is not the case for the train wheels. Instead, train wheels rely on the conical shape to achieve the differential action. When the track has a turn to the left, the wheels will go slightly to the right relative to the track. This will make the contact point on the right wheel will be at the larger cross section of the conical shape, while the contact point on the left wheel will be at the smaller cross section of the conical shape. We know that the rolled distance is omega, which is the angular velocity, multiplied by r, which is the radius. If we assume the radius in contact for the right wheel to be R capital and the radius of contact for the left wheel to be R small, which is less than R capital. This means the rolled distance by the right wheel is omega R capital and rolled distance of the left wheel is omega R small, which means for the same angular speed, the conical shape has enabled the two wheels to roll different distances and hence achieved differential action. In addition to that, the net force of the wheels will be to the center of the turn to supply the centripetal force needed for the turn.